My name is Dr. Jack Lewis. I'm a neuroscientist, and I'm on a journey to understand everything there is to know about the human brain. The human brain is the most complex part of our body. Many mysteries remain about how this most vital of vital organs controls every aspect of our lives. But over the last few decades, our knowledge has expanded in leaps and bounds.
That was a shock to the system.
Now we're getting ready to push it to the limits, finding out how our brains react to unusual conditions and surprising challenges.
This is the strangest experience of my life.
Let's do it. I'm setting out on a journey. A journey to meet some people with remarkable neurological conditions.
One of the most common questions is, how is it wired to your brain?
They give us a unique insight into the inner workings of the brain.
I discovered people who are able to remember almost every day of their life.
In this episode, we'll mess with your mind to find out how our brains control our experience of pain. I'll push my pain barrier to the limit with high voltage.
Ow! That was a shock to the system.
And sub-zero temperatures. To get there, I'll be coached by a man who has trained his brain to withstand extraordinary levels of pain.
5 minutes, submerged up to here.
And you'll find out how brains generate fear and anxiety.
How good are you at dealing with pain?
I'm joined by magician Pete Heat, who will reveal that pain can often be all in the mind.
Don't worry, before you answer, I'll tell you, I'm not going to hurt you.
What's going on deep inside your head? Join me to uncover the secrets of the brain. Chin chin. Imagine a life without pain. No throbbing headaches, no stinging sunburns, no aching joints. If you think that sounds great, think again. Pain may be unpleasant, but it's vitally important. It could even save your life. It tells us when we've injured a part of our body, and it gives us a sense of how serious the damage is. It serves as a reminder, helping us to protect that body part so that it can heal. Without pain, we'd be in trouble, big trouble. But how does it work? When we injure part of our body, it hurts, but only because our brain says so. Damage-detecting sensory neurons flash a message to the spinal cord. The spinal cord neurons relay the message to the brain, which creates the actual sensation of pain. But sometimes it isn't quite so straightforward. Our brains can get easily confused by the messages from our other senses, as magician Pete Heat knows only too well. Next, he'll be living up to his name by turning up the heat on an extraordinary magic trick.
How good are you at dealing with pain? Don't worry, before you answer, I'll tell you, I'm not going to hurt you. I'm going to kind of flick through the pack like this. And I'm going to get you to say stop somewhere in the pack, so wherever you want.
Stop.
Is that about right? I can go further if you want. You happy? You sure? Okay, I wanted you to know that it was a free choice is the important thing. Yeah, okay. Can you put one hand out like that? But I'm going to look away, but I want you guys to look at what the top card is where you stopped it. Is everyone seeing that? Yeah? Can you see that? In fact, can you put your other hand on top of it, like that, to cover it up? Yeah. Okay, just so I can't do anything sneaky. So remember that card, yeah? Okay. Now, bearing in mind what I just asked you, I've got a lighter here. Now, I am going to light this, and I am going to hold it under your hands, but I'm going to hold it very low down, so more near your knees, and you will feel warmth because heat rises, obviously, but it will be a very slight on the back of your hand, don't worry. But I want you to close your eyes as well, just so you're just concentrating on what you're feeling rather than seeing. So close your eyes quite tightly for me, okay? Hold on. Yeah, sorry if I can light the thing. Yeah, brilliant. Okay, don't worry. And now it's all right. I'm going to hold it underneath your hand. Okay. So very low, about knee level now. Can you just about feel that warmth from the back of your hand there? Concentrate on what you can feel. Yeah. Okay. Good. Can you feel that? Yeah. Yeah. Okay. Can you feel that? Yeah. Okay. Yeah. Good. Okay. Now I'm gonna I'm going to raise it slightly higher, but obviously not burn you, so tell me if it gets too hot. You feel like getting slightly warmer now? Concentrate. Yeah, okay, all right, I'll stop there. I don't want to burn you, all right? Okay, I'm going to take it away. Can you open your eyes for me? Now, the weird thing is I haven't actually got a lighter in my hands, okay? I put that in my pocket. I know, you did, but I mean, correct me if I'm wrong, right? But correct me if I'm wrong. You weren't just saying that just to go along with it. You could actually feel that getting. Yeah, exactly. So you could feel it get warmer. No, that's important. Like you weren't just saying it because you felt the pressure under the cameras to say it. And that's the interesting thing. So you could feel an actual heat on the back of your hand, right? Now, yeah, it is weird, isn't it? Because you saw I didn't have a lighter there the whole time, right? But the heat was real. Open your hands for me and look at the card now. In fact, show that camera here. Show this camera.
I can't do this.
Okay.
This is really creepy. Is that an actual handprint? Oh my god!
Pete's magic plays on the complex relationship our brains have with pain.
I only felt like the slightest bit of heat, but there was definitely heat. But
Genuinely feel those?
genuinely felt heat. Really? Yeah, genuinely. And I didn't know how it happened, but it obviously happened.
You'd already mentioned, are you good with pain? It definitely put that thought in my mind, and then getting the lighter out. Yeah, I was prepared to burn.
We're amazed because we tend to think of pain as a straightforward process, that our bodies feel the pain and send it on up to the brain as a one-way message. But it simply doesn't work like that.
Surely you'd be able to feel heat through your skin. If there was real heat, you could easily tell. But if there's just the notion of it, I don't think it'd have that much power in actually making you believe that there was a heat source underneath your hands. So that's quite weird.
The thought of there being a fire there, and it made myself feel as though I need to prepare for that and be aware and move my hand away if I need to.
As Pete's trick shows, the brain plays a much bigger role in deciding the pain we feel than many people realise. But if it's possible to feel pain that isn't really there, does it work the other way round? Could we use mind over matter to switch off pain sensations that are there? This is a question that's about to become very important to my future well-being. I've arrived in a place called Blaricum in the Netherlands. I'm joining 300 people who are about to do something that most people wouldn't dream of doing slap bang in the middle of winter. They're going to stand neck deep in really cold lake water for over 5 minutes. Why? Because they believe that not only will they not feel the pain, but also they'll hardly feel the cold. Now, I hate the cold. I'm a huge wimp in that regard, and like most people, I'm not that keen on pain either. But I've been set a challenge to join them. So will I take the plunge or not? Well, to find out, we'll need to rewind to my very first meeting with the man who's responsible for this whole bizarre enterprise. Wim Hof is a Dutch daredevil, more commonly known as the Iceman, for his ability to withstand extreme cold. Wim claims to be able to control his autonomic nervous system, and that this ability can be learned. He's a man who could give us a genuinely extraordinary insight into how our bodies can control pain. By the time Wim reached his teenage years, he was already comfortable running barefoot through the snow, but it was a personal tragedy that pushed him to take this to new extremes. In 1995, he began to experiment with ice baths, building to his first world record attempt.
Hey Wim, hi.
Hi.
How you doing?
Jack.
Lovely to meet you.
That's the way.
How are you?
Right on.
Are you not, I'm all wrapped up like this, are you not a touch cold?
No, I'm used to.
Yeah?
So anybody can do this, but you have to get used to it.
You say anyone can do this, but I am terrible in the cold. I'm a wimp, look at me, I've got 4 layers on.
That's only a vascular condition of being so much in the comfort zone.
So if I get out of my comfort zone, I'll be able to cope with this kind of cold?
I will teach you.
Yeah?
Today.
Let's do it.
This morning.
I can't wait.
How How could Wim not feel pain when submerged in ice for over an hour? How could he climb to an altitude of 22,000 feet in nothing but shorts and shoes? This man has some explaining to do.
I know a little bit about what you do, but one of the key questions that I've always been fascinated by is, where did it all come from?
I lost my wife in '95.
Oh, no.
And 4 children with her. So I brought my own children up alone. And
single parent?
Yes, with a lot of grief and broken heart.
It's not in our collective knowledge how to deal with that kind of loss.
Exactly.
Yeah.
So I found my silence within by going into nature and exposing my body into extreme nature until this stillness, this peace inside, the power of life itself came back on again.
So once you started getting that feeling, you then thought, presumably, I need to do more of this. I need to explore further. Where did the breathing come into it? The element of breathing, how did you discover that that was important?
I began to notice that if I began to breathe deeper, I was able to stay longer in the ice. And this big sensation, this deep sensation of being came into me and made me able to oxygenate so much that in 25 of deep breathing breaths, I could stay like 5 minutes or 7 minutes under the ice.
Can you teach me some breathing techniques like now?
I got some cushions.
Yeah.
We relax and that's the way.
Brilliant.
Let's go. Deeply in. Letting go. Take him in. Become lightheaded. Loosen the body. Tingling. Now the last one. Deeply in. Letting go. Stop after exhalation.
Wim is able to hold his breath with ease for over 6 minutes, while his entire body is submerged underwater. Cold water, obviously. He claims it's possible for everyone, and that the foundation lies in proper breathing. Through some very simple breathing techniques, he believes you can learn to control not only various aspects of the autonomic nervous system, but even your immune system too.
Okay, breathe in. Keep it in for 10 seconds. You had 1 minute, 10 seconds without air in the lungs. Okay, let's go into the second round.
Let's do it.
Last one. Fully in. Letting go. Stop. Just let the chemistry do its work. 140 almost. 20 seconds more to 2 minutes. 150. That's good enough. Get it in.
Keep it 10 seconds. And press a little bit to your brain. It's like natural drugs. You ignite.
But you said press a little bit into your brain.
Yeah.
I just shot through all my knowledge of the anatomy of the brain, the cranium, and I was like, nah, that's not possible. And I tried it and it felt a lot better. I don't know how. Yeah, I think you're going to rewrite some anatomy books too.
Now we are going to do push-ups without air in the lungs. There we go. Ready? Go. 30. Feel it.
I was high after 5.
Yeah. Good. Stop. Push up.
After the breathing and meditation exercises, Wim wants me to challenge my body and see how this has affected my pain threshold. 40 push-ups should do the trick.
40.
I got to 25.
Yes.
And then I forgot where I was and I was going faster.
Yes.
That was brilliant.
Right on.
With no oxygen.
How do you feel?
I feel good. I feel great. I'm not going to lie, good isn't enough. I feel great.
In the last 20 minutes, I've held my breath for longer than ever before and completed 40 press-ups without feeling any pain. Wim believes his breathing techniques have short-circuited my ability to feel the burn.
I've heard of the concept of if you stimulate pain receptors, then after a while they stop sending the messages so much. But I've never come across the concept of switching them off even before you've done anything with them.
Yeah.
That's amazing. It kind of makes me want to jump into cold water, but actually, no, because anytime I get in cold water, I always get a cold. So I'm not going to do it. Wim Hof is one of the most inspirational people I've ever met in my life. But even though he's very charismatic, I'm extremely skeptical. If there's no scientific data, I will be very dubious about what I'm being told. So, coming up, I'm going to meet the scientific community who've taken a closer look at what's really going on inside Wim's body. What Wim's extraordinary techniques show us is that we all have the capacity to suppress pain. But you have to be pretty bold to sit in an ice-cold bath for a whole hour. Which makes me wonder, is it possible to switch off just the anxiety part of the pain sensation? Well, it's easier said than done. So, what is the relationship between fear and pain? Between our anticipation of pain and its reality? To understand, we need to look at the part of the brain that responds to potential dangers, the amygdala. To keep us alive, it's evolved to keep us super sensitive to threats and perils. To speed things up, it receives direct inputs from our eyes, nose, tongue, and ears. These special subcortical pathways bypass the outer part of the brain where sensory perception is usually generated, allowing us to detect threats subliminally and respond to them before we even realise there's a problem. So, for example, a faint smell of burning can make us feel anxious, even when it's below a level we can detect consciously. Want to see your amygdala in action? Have a listen to this. All you have to do is listen and see how these sounds make you feel. Ready? Now calm down, no need to panic. It's only Pete. You just fell victim to your ever-watchful amygdala. Your ears perceived the music as a threat, so assumed your eyes and other senses would follow. How did you feel when you heard those sounds? There's an evolutionary explanation for this sudden onset of anxiety. These sounds are similar in pitch to the cry of a baby, and because we're hardwired to respond to any potential danger, to us or our children, feelings of fear and concern rapidly escalate. Okay, so our sense of hearing is finely tuned to detect any sign of danger in our immediate environment. A single alarming sound and the adrenaline instantly kicks in. But what about vision? Here's a simple demo to show you. Have a look at this series of images. Did you recall seeing this phone, for example, and the kitten? It's unlikely. At this speed, it's hard to see an object long enough for it to stick. Now take a look at this next series of pictures. Did you happen to see the spider and the shark? It's highly likely. Now, this second selection of images was played at exactly the same speed. We just replaced the kitten and the phone with the spider and the shark. So why would your brain prioritize those images? Well, your amygdalae leapt into action to spot the threat. In fact, all our amygdalae are triggered when we see a dangerous animal or simply by being put in a situation we don't like. What makes you scared?
My greatest fear is spider.
My greatest fear is probably spiders. Anything that have a lot of legs. I don't really like legs.
If I see a spider in my room, I cannot sleep from the night.
Fear of spiders is one of the most common phobias, and largely irrational given that we're much more likely to kill them than they are to kill us, in the UK at least. One prominent theory states that early on in human evolution, spiders must have posed a deadly threat for us to have developed such a hair-trigger reaction to them. We're all terrified of spiders, right? Time for magician Pete Heat to find out just how much.
This one involves a little app, right? It's not really a magic thing as such, but I'll show you what I mean. Can I take a picture of your left hand?
Yeah, you go.
Okay, yeah, do you want to do it? Okay. Okay, so now if I put that there, it looks like that is your hand, right? It looks like we can see through. And now this is what the app does. Like, it basically makes it look like there's a little spider walking across there. Okay. In fact, I think it's motion activated, so I'll try and bring him back. There he is. So this isn't the trick, by the way. This is just a weird little thing. But actually, if you wave your hand over it.
Oh my God!
So if you wave your hand over it.
Fucking hell! Oh my god! I don't like spiders.
It just goes to show how amusing our instinctive fight or flight response can be in the hands of the right prankster. If our sense of fear, anxiety and stress are all hardwired into our brains, is there any way we can override such a primal response? So we know that it's our brain that sets off the alarm bells when we're under threat. But what then are the physical responses that kick in? In other words, what happens to our body when we're scared? Here's one way to find out. I want you to be nice and calm for this next experiment. Have a look at this pendulum and just allow your eyes to follow it swing back and forth. Back. Sorry if that was a shock, but if we got you, then hopefully your body is now exhibiting all the classic adrenaline-fueled symptoms of fear and anxiety. When our amygdala rings the alarm bells, our heart rates shoot up, our breathing patterns change dramatically, and you get that knot in your stomach. Neuroscientist Sarah Garfinkel has been studying the interplay between our bodies and our brain in relation to how we process painful memories. It's a fascinating area of research. It's not often that I find myself actively seeking out painful experiences, but that's precisely what today is all about. And Sarah's about to make me feel very anxious. She set up a pain lab, and I'm today's guinea pig.
So this is Dr. Cassandra Gould, who
Hi.
is an expert at setting up these types of experiments. So
Great.
Cass, go for it.
This experiment has two parts. The first part, we're going to define a shock threshold, like an intensity of electric shock, which you think is uncomfortable but not painful.
So, stage one, establishing my pain threshold. Unless you're being wired up, it's not a proper experiment, is it?
Definitely not. Next, we're going to put the electrodes on you that's going to give the electric shock. So we've got some nice conductive paste to make sure the shock goes right through you.
I'm not going to lie, now the electrode's on, and I can see it's a proper heavy-duty piece of technology. I'm a little bit apprehensive, if I'm honest.
Well, we're interested in fear, so this is exactly the effect that we're going for.
So, do you feel all nice and secure? You think your hand's going to stay still?
I've never felt safer in all of my life. Not.
Okay, so we're going to begin the thresholding part now.
You mean the painful part?
The painful part. Are you ready to begin?
Yes, I am ready to begin.
Okay.
And so it begins. Increased levels of electricity will be zapped through my arm until I reach a point that feels genuinely uncomfortable.
Did you feel anything then?
It hurt a little bit, not much.
So it's still uncomfortable but not painful.
Ow! That was a shock to the system. So
Yeah?
I wouldn't want it to get any worse than that. Let's stay there. I just had 82 volts sent through my body.
Ow!
And it's not nice. Well, I don't think we need to duck it down.
Okay.
I'm scared,
You're
of
scared?
that. Not scared, but I'm wary
Okay.
of that happening again. Like, that's not pleasant. So are they just sadists? Or is there some science in here somewhere? Well, I hope so, as it's on to stage 2. Now the experiment is simple. I'm going to be shown a series of images, and one of them will be accompanied by a shock. But will my brain begin to anticipate and maybe even fear the pain just on the basis of this recurring image?
Before and after the experiment, I'm going to ask you to give some ratings about these pictures. So they're just abstract pictures that probably don't hold much meaning for you now, but after you've seen them on the screen, they might be more important to you. We'll do one set before we begin, after we've done the electric shocks, and then one set after as well. Okay? If you can sit back for me and get comfortable. And the experiment will last about 10 minutes.
Okay. So the shocking experiment begins. Can I be taught to fear an arbitrary geometric symbol through electrocution? Ow. The answer is yes. Oh, the weight is killing me. Within minutes, I'm starting to feel genuinely apprehensive about a small grey flower. Will I be scared of it for life? Thankfully, Sarah thinks not.
What we've done now is we've created a fear response by associating these symbols with electric shocks. But now we would do something called extinction, which is where we show you the symbols repeatedly, but they're not associated anymore with electric shocks. And then we can do something which is called extinguish the fear response. And that's where both your body and your brain learn that these shapes are now safe.
That's happening for me with these arbitrary geometric shapes, but presumably you could do a similar thing with images of things that people are genuinely scared of.
One of the big ways of treating phobias is to expose people to the thing they're most scared of. But if people avoid it and don't go to the end and don't really go to the full course of exposure therapy, then they can still be very scared of the thing they're scared of. They have to really experience the thing in its whole entirety in order for the fear response to be properly extinguished.
But this experiment hasn't just been about my fear response. For Sarah, it's part of a much bigger study into the relationship between our brains, fear, and our hearts.
Your heartbeat is speaking to the computer, which is generating these images, and they're being shown either exactly when your heart is beating or in between heartbeats.
That's very interesting, but why? Why?
Because what we're able to show is that something which is processed when your heart is beating is more fearful. That it's exactly when the heart is beating, you let in all the fear. You let in all the fear, but then you learn it's safe. So you have a big fear response, but you need a big fear response in order to see that nothing bad has happened.
Well, I would say thanks, but it's been horrible, so...
Well, you've helped science, so we'll thank you instead.
I would have thought that if you had an increased awareness of what's going on in your heart or your breathing, that would only make the fear worse. But it's actually the other way round. A greater awareness of your body can help to diminish that overactive sense of fear or anxiety.
We believe that accurate knowledge of your heart can actually help your brain understand what your heart is doing. So each time your heart beats, it signals a response to the brain, which activates areas such as your amygdala that's involved in fear. But if you're good at knowing when your heart is beating, then you know that the response in your brain is potentially driven by your heart. And through further understanding, uniting this loop between brain and body is a way of therefore understanding where these signals are coming from and actually potentially that serving to reduce the fear response.
Now, making me feel scared of a weird geometric symbol might seem a bit strange. But actually, this research has serious implications for both science and medicine. Sarah's experiments back the idea that fear can not only be learned, but also potentially extinguished.
The point is that when it comes to pain, we should all pay attention to our physiology. Listen to and control your body, and you could better control your brain. Now, sadly, I'm not able to electrocute strangers to see if I can apply her theory in the real world, but it is possible to set up a simple experiment which shows how a simple change in our bodies can improve our brain function. I've pulled together 4 willing volunteers to a gym to show how your body can rule your brain. All you need is a pair of chopsticks and some spinning plates.
Christy, have you ever done this before?
Once when I was a kid.
So, a few years ago.
Quite a while.
Okay. All right, well, look, maybe this will help you, maybe it won't. Here's a chopstick, if you could put it in.
To start with, I want the first team to hold the chopstick in their mouth in a particular way.
Now shove it in the middle.
Yes!
Oh, it's so close. Oh, stop. This one's stopped now. Well done, 4.
Yeah.
So you've never done this before?
No, never.
Feeling confident?
So.
So if you could stick this in your mouth sideways on. Perfect. Let's see how we get on.
Now for the second team, I'm asking them to bite onto the chopstick in a different way. Think this might make a difference? Take a look. So what's going on? Oh, he's got 5. Stop. This one has stopped. Good effort, sir. So you got 1, 2, 3, 4, 5, 6, 7, which is excellent. You happy with 5?
Yeah, I'm pretty happy with 5.
Not bad for a complete beginner.
For a complete beginner.
Good job, sir.
Thank you.
Nice one. How could that possibly have helped you? Any
Was it
idea?
distracting my brain from thinking about that instead of what I was thinking too much about what I was trying to do?
Close, but no cigar.
Ah.
I'll tell you in a sec. You're probably wondering what the hell this had to do with everything.
Yeah.
Well, it's all to do with the facial feedback hypothesis. Every single time you've ever felt happiness, it's probably more often than not been associated with a smiling facial expression. By pulling a smiling facial expression, it can make you feel that little bit happier. Conversely, when you pull a frown, because of all those times you spent sad, simply by pulling a frowning sad face, it can make you feel incrementally sadder. And of course, when we're happy, we perform better. When we're sad, we tend to perform worse in any given task. So the idea was, those of you with the smiling facial expression would do a little bit better, and those of you with the sad one would do a little bit worse. And that's exactly what we found.
It definitely made a difference. I wasn't sure if it's because I was concentrating on the stick in my mouth rather than worrying about what I was doing. But actually, it was much better than I thought I was going to be, so it obviously worked.
So, what have we learnt so far? Wim's extraordinary abilities, Pete's tricks, and my torture session all reveal the same thing. Our experience of anxiety, fear, and pain are far more complicated than you might have thought. But one thing is becoming increasingly clear. It's definitely possible to manipulate the messages en route from body to brain. Increasingly, science is starting to understand how you can use your brain to cheat your body and your body to trick your brain. So if you want to take control of your body, there are some surprising things you might want to try. Now I'm about to see if I can submerge my entire body in icy water. Let's see if there are other tricks you can use to withstand the pain of extreme cold. Okay, here we have a lovely bucket of ice. It's not a test of strength or who's the hardest. It's about getting to the point with your fist sunk all the way down to the bottom that it starts feeling uncomfortable. At the moment, you're like, you know what? I don't like this. Pull it out. So Ashley, if you want to go first. Not nice. After you. Get stuck in. Go on, David.
Oh yeah, that's really like a bit sore now.
Great. So everyone's thresholds are completely different, so there's no winners or losers here. But what we're going to do this time is get you to do exactly the same thing, but instead of being silent, we're going to get you to curse. Maybe not curse, but at least shout and see if that can subtly change the threshold, the point at which the discomfort kicks in. Have a go. Whenever you're ready, we're looking for the point of discomfort. Louder! It only works if you do it loud.
No, that's it.
Next up.
Okay, no.
Give us a good shout. Come on.
Ow! Oh my God! That's enough. Ow!
Oh! It's ice! Ah! Ah, this ice! Ah, the green bucket! Ah! 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 Yeah! You can do this! Ah!
So did any of you find that when you're allowed to shout and curse, that it made it easier to withstand the cold?
Well, yeah, I definitely kept my hand in for longer. I didn't really notice the discomfort because I was just
I suppose, letting stuff out.
As Ashley said, you focus on something else and you're not too distracted by the water.
Now this is just a simple experiment, but earlier on we met Wim Hof, a man who's trained his mind to overcome fear and his body to overcome pain. But what is it that Wim is doing that most of us can't? How does he maintain that level of control? It's a question that Wim himself is curious to answer. He's been working closely with scientists to try and understand what's happening to his mind and body. Matthias Cox and Peter Pickers are professors at the Department of Intensive Care, Rathbode University. Their speciality is the immune system. They think that Wim's technique could be the key to not only understanding immediate discomfort, but also, potentially, chronic pain. Their studies show that he can control his autonomic nervous system, something that science previously thought was impossible.
A lot of people ask, how did you get in contact with Wim Hof? But actually, he found us, we didn't find him. He was doing an experiment in the Department of Physiology, and he was standing in ice, what he does often, and they were measuring his baseline metabolic rate. And it was actually quite amazing that his baseline metabolic rate went up with 300%, and his core temperature went up, not down, when he was standing in ice. And while he was there, he mentioned, by the way, I can also influence my immune system by using my techniques.
Hey.
Hey.
Hi.
Hi.
Yeah. How are you? Good to see you again, man.
When we started to work with Wim Hof, we were actually quite reluctant. I looked him up and I watched his movies on YouTube and I found out the things that he did. So we said, well, he's a little bit of a crazy guy, but he has done things that are really, really remarkable. So maybe we should give him a chance. His first claim was, I can modulate my immune response. But then he came with his second claim and he said, I can teach this to other people. And so then we said, all right, in that case, we can do a study in which you train healthy volunteers that have no experience with meditation, with cold exposure, with anything. We injected them with endotoxin, and when the numbers came back, they were amazing indeed.
What we wanted to talk about today is the next study.
We've seen in the previous study that using your whole set of techniques, you can modulate your immune system via your autonomic nervous system. And now we, as Professor Pickers alluded to, we want to peel it apart.
So the brain is one thing, but we have the breathing techniques and we have the exposure to cold. And so we want to dissect how important it is to do the three combined, or maybe we can leave out one or two and make it more feasible for older people or patients.
Yes, exactly. I was thinking about that too, to make it accessible, simple and effective for any person, and for that I'm very, very grateful.
So what does modulating your immune response really mean? And how could this help people with chronic pain? The role of the immune system is to protect against disease or other potentially damaging foreign bodies. But sometimes our body's immune system attacks and destroys healthy body tissue by mistake. There are more than 80 types of autoimmune disorders, and often this can lead to chronic pain. Matthias and Peter's research with Wim explores the notion that humans can consciously control their immune system, which could have important implications for the treatment of a variety of conditions. Before now, both the autonomic nervous system and innate immune system were regarded as systems that could not be voluntarily influenced. This research has shed new light on their relationship, and in the process, the Rathbode team have begun to challenge established medical theory.
If you could modulate your immune response by just doing these techniques, this would help in patients with these diseases. The immune response we measured during endotoxemia is a very objective measure because we measure it in the lab, it's proteins in the blood, And we found indeed that with the techniques that you teach to the healthy volunteers, they were able to modulate that.
If you look at the textbooks, the autonomic nervous system, the name says it, it's autonomic. So you cannot willingly or voluntarily influence it. That goes also for the immune system, actually. It's something that you have no influence over whatsoever yourself.
There are many, many diseases that are caused by hyperinflammation, too persistent, too pronounced immune response.
If we would be able to show that this works in patients, it would be a method in which patients can do something about their own disease.
So you know what we are planning and what we will do?
Most exciting.
Yes, and we will keep you informed.
I love science.
Keep in touch.
Thank you very much.
See you next time.
Bye-bye.
Bye.
Bye.
My big day has almost arrived. Tomorrow, I'll join 300 people who are ready to put Wim's technique to the test. It's clear that Wim has opened some fascinating lines of inquiry for the scientific community. But I still need to understand why and how this can stop me feeling the extreme pain caused by freezing water. Luckily, I've booked in for a late-night pep talk from one of the strongest advocates of the Wim Hof technique, Pierre Capel, Professor Emeritus of Experimental Immunology at Utrecht University. The Wim Hof method involves several different components. Most obviously, there's the breathing technique. How does that contribute to his ability to control his bodily sensations?
If you ventilate and you blow off CO2, he gets rid of excess of CO2. It changes the pH of the blood. The pH rises. At a higher pH, you don't feel pain.
So this explains why I could do so many push-ups. There are all kinds of pain receptors around my body, and Wim's breathing technique was seemingly able to disable some of these by raising the pH level in my blood. But how does this affect fear or anxiety?
If I have the breathing which Wim Hof is teaching, then I dismantle my pain perception. But the same receptor is the anxiety receptor in the amygdala. So I have no pain and no fear and no anxiety due to the breathing. But the cold generates a total change in metabolism, a total change in blood flow, upregulation of adrenaline, which is fantastic. So if you disconnect pain and anxiety from survival, then you only have survival and you can walk up a mountain.
Wim describes the fact that he's in a very specific state of mind, which could be described as meditation.
Sure.
How does that influence the overall sort of mind over matter phenomenon?
Stress in the natural way is good, but that has a time frame. It starts and it stops. Chronic stress has no start and no stop. The natural stress reaction is life-saving. The chronic stress is life-ruining. And so if you do the Wim Hof method by breathing for 20 minutes, which is a type of meditation, then you switch off the devastating effect of the chronic stress.
Being active, meditating, breathing, special breathing practices, all of these things can actually boost your overall level of well-being?
Yes, and it spirals.
We can even extend our life.
Just enjoy life for half an hour all by yourself. That is it.
Well, I'm convinced. At least enough to make my way to the big event. Today's mass cold immersion has been organised by a man called Henk, who says his life has been changed by Wim's methods.
I had rheumatism on a really bad form. I had a lot of medication. If a doctor gives you a pill, you're only waiting for the doctor to take another pill. And if you have pain or suffering from anything, from a disease, you're only trust on your pill. After working with Wim, I took it down for 1 injection every 3 months instead of every week. So I cut down my medication and I started really feeling stronger, very healthier, more powerful. Never lose your contact with your doctor. Don't think it's a medicine, cold water, because it isn't. But starting to know yourself, and finding yourself, you find your own way to much more.
The youngest participant is 11 and the oldest is 72. And the latest temperature test has the water at just 5 degrees centigrade.
Okay,
First, Wim warms everyone up with his breathing techniques. Warming up alongside me are people with a range of health problems, from multiple sclerosis to severe back pain. It's the big moment. I'm finally in the water, but will it work?
That was easy. You know what? It's not complicated. 3 30-second bouts of crazy breathing, and anyone can do that. Wimp no longer. Now I'm Wimp.
I can't believe I did it. If you ask anyone that knows me well, they will tell you I am terrible in the cold. I'm a real wimp. I'm always wrapped up with much more layers than anyone else. But today, I was in there for 5 minutes, and you know what? I don't know whether it was the Wim Hof effect or whether it was the Wim Hof method. But either way, I was right next to him. By doing all the breathing techniques for ages beforehand and all the muscle stuff, it meant that I brought up the pH of my blood by removing the carbon dioxide. That decoupled the proteins in my pain receptors, which meant that I didn't feel pain when I was in there. Then the muscles, as Prof. Capel told us, produced various myokines, which also changed the way your DNA expresses itself. And for all of these reasons and more, I was relatively comfortable in an otherwise very stressful situation. But Wim would, of course, kill me if I didn't point out that all I did was use the cold water to shock myself into its natural state. And as you may be able to tell, I feel high as a kite. So I would highly recommend it to anyone. And you wouldn't have caught me saying that 24 hours ago. Are you ready to push your pain thresholds to the limit? Well, personally, I'm not convinced I'm going to start every morning hyperventilating and then jumping in an ice cold bath. But Wim's technique sheds some fascinating light on the relationship between our bodies and our nervous systems. From how we can feel pain purely because our brains tell us to, how we can be taught to develop fear but also to overcome it, to the ability of the body to withstand much more pain than you'd ever think possible. Together, these remarkable stories take us ever closer to unlocking the incredible secrets of the brain. So no need to be scared then.